Are you ready to take your knowledge of matrices to the next level? In our previous video, we touched on the importance of matrices and their diverse applications in fields like seismology. But did you know that there are various types of matrices beyond just row and column matrices? Now, we're going to dive deeper and explore some other fascinating matrices that will expand your understanding of this powerful tool. Rectangular and square matrices. Rectangular and square matrices are categorized by their dimension. They're defined as having an equal number of rows and columns, forming a square shape. An array of 2x2 and 4x4 matrices, for example, are the square matrices. In contrast, rectangular matrices have different numbers of rows and columns, such as the 3x4 and 5x2 matrices. Row and column matrices are included in this latter category. Triangular matrix. Triangular matrix is a subtype of square matrix, where elements above or below main diagonal are 0. Let's consider two 3x3 matrices, X and Y. Matrix X is called the upper triangular matrix because it has zeros below the main diagonal, while the upper non-zero elements along with the main diagonal forms a right triangle. Inversely, matrix Y has zeros above the main diagonal, creating a triangle shape at the bottom. Hence, Y is a lower triangular matrix. We can have a triangular matrix from any order of the square matrices and may have 0 elements within the triangular-shaped elements. Diagonal matrix. Diagonal matrix is a matrix where all non-diagonal elements are 0. Matrices A and B in our examples here are diagonal matrices. Matrix C is also included in this type since the non-diagonal elements are 0, although one of its diagonal elements is 0. Identity matrix. An identity matrix, denoted as I, is a diagonal matrix where the elements of its main diagonal are all 1 while the rest are 0. If we multiply any matrix by the identity matrix, the original matrix remains unchanged. Note here that a matrix is considered an identity matrix if it has elements of 1 only on the main diagonal. So, the similar matrix with values of 1 on the anti-diagonal is not an identity matrix. Scalar matrix. A scalar matrix is almost similar to an identity matrix in that it has the same number or variable on its main diagonal and 0 everywhere else. In fact, a scalar matrix is the product of a constant and an identity matrix. We'll delve further into matrix multiplication in the next video. Null or zero matrix. Another kind of matrix is the null or zero matrix. Can you guess what it is? Yes, as the name suggests, it is composed entirely of elements equal to 0. Easy peasy. Negative of a matrix. To obtain a negative of a matrix, we simply change the signs of all of its entries. In the following example, all the positive signs in matrix D are changed to negative, and vice versa. Transpose of matrix. If we interchange the rows and columns of a matrix, we will get its transpose, denoted by subscript T. Transposing makes the order reversed. It means when matrix E is transposed to matrix ET, we interchange its rows and columns. The order 3x5 is reversed to 5x3. So if we transpose a row matrix, we'll get a column matrix and vice versa. Symmetric and skew-symmetric matrix. A matrix is considered symmetric if it is equal to its transpose, meaning that their orders and corresponding elements are the same. Hence, the symmetricity is a property that only applies to square matrices. However, a matrix also can be skew-symmetric if its transpose is equal to its negative. For example, consider matrix F. Matrix F is different from its transpose, yet the transpose and its negative are the same, ft equals -f. Therefore, matrix F is skew-symmetric. A matrix can be put into a few types, like the following one. Apart from being a square matrix, do you know what category matrix M can be put into? Comment below. Thank you for your continuous support, especially our valued patrons and members who have been encouraging us to keep producing more quality content.